Counting principles. Counting principles, it refers to the rules for finding the number of possible outcomes. It can be addition principle of counting or multiplication principle of counting, which is also known as fundamental counting principle. So first, let's have the addition principle. If event A can occur in M ways and event B can occur in N ways, then A or B can occur in M plus N ways. So we have here the word or. So that will tell us that we're going to have an addition principle. So you have M plus N ways. Let's have example number 1. Poy's Bakery has 12 Spanish bread, 10 ensaymada, and 14 pan de coco left at the end of a day. How many types of bread can you choose from? So we have 12 Spanish bread plus 10 ensaymada plus 14 pan de coco. So we'll have 12 plus 10 plus 14. So we have 36 choices. Example number 2. The Supreme Student Government requires one student representative from either first year or the second year or the third year. So if there are 28 first year, 35 second year, and 39 third year qualified students, how many different choices for representatives are there? So since we have different choices from the first year or the second year or the third year, we'll have 28 plus 35 plus 39. So again, we have 28 plus 35 plus 39, that is equal to 102. So there would be 102 choices for representatives. Multiplication principle. Suppose that two events happen in order. If the first event can happen in M ways and the second in N ways after the first has happened, then the two events can occur in M times N ways. So unlike in addition principle, we use the word or. So in multiplication principle, we use the word and to denote that we're having multiplication principle. So let's have an example. Rose Ice Cream Parlor offers 12 flavors of ice cream, which can be served on a waffle, sugar, or plain cone. How many different single scoop ice cream cones is possible to buy at the parlor? So since we have 12 flavors of ice cream, we can have 12 flavors of ice cream in a waffle, or it could be served in a sugar or in a plain cone. So we can have 12 times 3 because we have waffle, sugar, and the plain cone. So that would be 3 times 12 or 12 times 3. That would be equal to 36. So there are 36 ways of choosing a single scoop ice cream cone at the parlor. Another example, in 2014, automobile license plates display 3 letters followed by 4 digits. So how many such plates are possible if repetition of letters is allowed and not allowed? So let us have first the first condition wherein the repetition of letters is allowed. So again, we have 3 spaces for the 3 letters followed by the 4 digits. So we all know that for the 3 letters, so having letters, we have 26 letters. And since repetition of letters is allowed, we can have here 26. So we can use 26 letters. Since it can be repeated, or the letter could be repeated, let's say we use A here, we can also use another A here. So that would be another 26 and 26. So we have 26 times 26 times 26. And then for the digits, so since we have numbers and digits, so we have multiplication principle, or the fundamental counting principle. For the digits, we have 0 to 9, so there are 10 numbers. So we can use 10 times 10 times 10 times 10. So it's because the rule only is the letters can be, or the repetition of letters can be allowed. So with regards to the numbers, there is no rule. So that means we can allow it. So therefore, if repetition of letters is allowed, we have 26 times 26 times 26 times 10 times 10 times 10 times 10. That is equal to 175,760,000. So that would be the possible license plate is 175,760,000. Now for the next condition, if the repetition of letters is not allowed. So again, we have the 3 spaces for the letters, and then for the numbers or digits, we have 4 spaces. So if repetition of letters is not allowed, so at first we have 26 choices times, if we use, let's say, letter A here, our letter A cannot be used on the other space. So it would be 25. And then let's say we use B. So we already used 2 letters. So that becomes 24. And the same thing with the numbers as we have used a while ago. The numbers have no restriction. So it will be 10 times 10 times 10 times 10. So again, we have 26 times 25 times 24 times 10 times 10 times 10 times 10. And that would be equal to 156 million. So that would be the possible license plate if the repetition of letters is not allowed. Another example, if a lottery game is made up of 3 digits from 0 to 9, what is the total number of possible outcomes? So with regards to these, we are dealing with multiplication principle again. And then we have 3 digits. So we have 1, 2, 3. From 0 to 9, so we have 10 numbers. So it is not mentioned that there is a restriction. So that's why the numbers or the digits could be repeated. So that would be 10 times 10 times 10. That would be equal to 1,000. So there are 1,000 possible outcomes.